Okay, so today we're on page 3 of our Chapter 8 notes packet. We're looking at log relationships, or in other words, properties of logs. So there are certain rules that we have to follow. The first one is we have the product rule. If you have log base b of the product a times b, this would expand to, the rule is, multiplication expands to addition. All right, multiplication is going to expand to addition. So log base b of a times b is going to equal log base b of a plus log base b of b. It's sort of like distributing the log in the base, but the multiplication expands to addition. Or, now this is ln, this is a lowercase l and a lowercase n, and we read it as ln, which is the abbreviation for, or the symbols for, natural log. So we can either write it natural log or ln, but I'll just refer to it as ln. So ln of a times b would equal ln of a plus ln of b. ln is another way of naming the natural log. So still think of it as just log. The quotient rule, if you have log base b of a quotient a divided by b, division expands to subtraction. So we would have log base b of a divided by b is going to equal log base b of a subtract log base b of b. Or if it was in the form of the natural log ln, ln of a divided by b of this quotient would expand to ln of a subtract ln of b. And if you have a power, the power rule, a power goes to a multiplier. We have log base b of a to the x, the power x. So what happens is that power x comes out in front as a multiplier. That's going to come out in front as a multiplier. So this would be x times log base b of a. Or if we had ln of a to the x, and that power would come out as a multiplier, so that would be x times ln of a. 3 more things to remember. All right. When you have log of a product, the product rule says we expand to addition. Division expands to subtraction. And a power comes out in front as a multiplier. Note, there is no rule for log base b of a sum, a plus b, or log base b of a difference, a minus b. Now these rules can be combined in a single expression. Also, always rewrite radicals in exponential form. For example, if you have the square root of x, you would write that as x to the exponent 1/2. Or if we had the cube root of y, we would write that as y to the 1/3. Right? So any radicals, write as fractional exponents. Okay, so we want to expand here. Expand each expression using the above properties. All right, so we have log base 4 of this product. 4 times x times y, right? 4 times x times y is what we have inside there. All right, so each multiplication expands to addition. So this would equal log base 4 of 4 plus log base 4 of x plus log base 4 of y. Number 2, we have ln of x to the third. So here we have a exponent or power. This power comes out in front as a multiplier. So this would equal 3 ln of x. Number 3, we have log base 2 of 16 divided by a. All right, so here you have a quotient or division. Division expands to subtraction. So this is going to equal log base 2 of 16 subtract log base 2 of a. Here we have ln of a squared times the square root of x. All right, well first a squared times the square root of x we would write as x to the power 1/2. Okay, now applying our rules. The multiplication is going to expand to addition. So I would have ln of a squared plus ln of x to the 1/2. All right, but let me go back. That power of 2 would come out in front as a multiplier, so it would be 2 ln a plus, and that power of 1/2 would come out in front as a multiplier, so plus 1/2 ln x. Number 5, we have log base 6 of, okay, we've got a couple things going on in the numerator. We have this multiplication and also a power. So let's think of this as, this is going to be x times y squared, and then divided by, division expands to subtraction, and let's write the square root of z as z to the power 1/2. So we're expanding. All right. So we have log base 6 of x plus, right, multiplication goes to addition, and the power is going to come out 2 log base 6 of y. Division expands to subtraction, subtract log base 6 of z to the 1/2, but the power of 1/2 is going to come out in front as a multiplier. So 1/2 log base 6 of z. Number 6, we have ln of x squared times y divided by z to the 4th. Okay, now just keep in mind these powers will come out as multipliers. The multiplication here expands to addition and division to subtraction. So we have 2 ln of x plus ln y minus 4 ln z. Number 7, we have division, and in our denominator we also have multiplication. Okay, so log base 5 of 25 subtract our denominator has 2 terms there. So let's put this in parentheses. Minus log base 5 of x This is multiplication, x times y squared, so plus, and that power of 2 comes out as a multiplier, plus 2 times log base 5 of y. Number 8, ln of 1 over the square root of e. Okay, let's rewrite the square root of e as e to what exponent? E to the power of 2. So now division expands to subtraction. So ln of 1 subtract 1/2 ln e, because the power is going to come out in front as a multiplier. Next page. We're going the other way. Okay? We're condensing. We have started in expanded form, now we want to condense. Alright, so we look at this and the operation of addition meant we had what to start with? Well, let's kind of recap. Right? Multiplication goes to addition, division to subtraction, and a power expands to a multiplier. All right, that's when we're expanding. And now we want to go in the reverse direction. All right. So if we are in expanded form, to condense, we go the other way. So that means this addition meant it was multiplication to start with. So it condenses to multiplication. So this means that we have log base 4 of 4x times x. Right? This comes to 1, and then this 4x plus x meant it was 4x times x. So this is simply log base 4 of 4x times x. That's it. Number 2. Oh, we've got a lot of things. We have this multiplier here that meant it was an exponent with our x, and another multiplier here that meant it was an exponent or power for our y. And subtraction meant that we started with division. Okay? So we have just one ln because we're condensing. So we have one ln x squared divided by y to the third. Let's look at the next one. Okay. We have addition, subtraction. Addition we know is going to condense to multiplication, and subtraction to division. But we have these multiplier here, which meant they were powers to start with. So we have just one log. We have division, so I'll write division as a fraction bar. And our numerator is x to the 1/3 times y to the third. So x to the 1/3 times y to the third. And we're usually not going to see a fractional exponent in condensed form, so I'll address that in the next step. And our denominator here is z to the 4th. Okay, or the other way of writing this, x to the 1/3 is equivalent to the cube root of x. So log of cube root of x, and most likely standard form would be to write the y to the third followed by the radical cube root of x all over z to the 4th. So we condense it all to one single log. Number 4, I've got to be careful. We have parentheses here. Okay, so I know that this subtraction meant we had division. So let me just start with my fraction bar for division. This addition meant we started with multiplication. So we have a times b to the 1/2. All right, so I'm thinking a times b to the 1/2. But b to the 1/2 is going to be equivalent to the square root of b. So I have a square root of b for my numerator. Let's not forget our ln. And the denominator is this. It's addition meant we started with multiplication. So the condensed form is CD. That's it. One single ln of a square root of b divided by CD. Number 5. We have log base 2 of 512 minus log base 2 of 64. Okay. Well, let's see. Subtraction in expanded form meant we had division. So this would be log base 2. Draw my fraction bar for division of 512 over 64. Number 6. We have lne plus lne plus lne. All these additions in expanded form and in condensed form, they're multiplication. So we have one single ln. We have e times e times e. And number 7. We have log base 2 of the binomial x squared minus 16, subtract log base 2 of the binomial x minus 4. Well, 1 log base 2. This is condensing to log base 2. The only thing that matters here is this subtraction. That subtraction was division to start with, right? It's the operation between the two logs. It's the only one that we're concerned with. That means it was division. And our numerator, x squared minus 16, and our denominator, x minus 4. Okay, so things to remember, right? If you are expanding, if you start off in condensed form and you have a multiplication, it expands to addition. Division expands to subtraction, and a power becomes a multiplier. And then you have to think about going in the reverse. If you're in condensed form, if you're in expanded form, addition meant it was multiplication in condensed form. Subtraction meant it was division in condensed form, and a multiplier meant it was an exponent or power. All right, so this concludes our video for tonight.